Okay, hello friends. Now let us have some of the examples using exponential form under Fourier series. Now see here, simple example is asked. It is a kind of a half wave rectifier waveform. So here it is, limit is 0 to pi on period, pi to 2 pi off period. So total period we have to treat as 0 to 2 pi. So fundamental period t will be 2 pi. That is the first thing. Second thing is we want to know omega. So for omega or omega 0, anything you can denote. So it is 2 pi f or 2 pi upon t. So that is 2 pi upon t is 2 pi. So 2 pi upon 2 pi. So it comes out to be 1. Now amplitude is given as Em. So our basic signal is m of t is equal to Em sin t for t 0 to pi, and for t pi to 2 pi. For t 0 to pi, it is this value, that is Em sin t. That is, it is looking like a sinusoidal function, as if it is a half wave rectifier kind of a half cycle. And for the off time, that is, it is remaining 0. So from pi to 2 pi, it is remaining 0. So this is as per definition and sketch, we have to take as m of t as our function under consideration for decomposition. Now using exponential form means we need to calculate two coefficients. One is C0 and second one is Cn. In case of trigonometric form, we calculate A0, An and Bn, and in exponential form, we calculate C0 and Cn. Now for C0, formula is C0 is equal to 1 upon T0, T0 to T0 plus T, m of T dt. The way it is for A0, that is the zeroth term. So C0, 1 upon T0, therefore 1 upon 2 pi over the period T0 to T0 plus T. So total period is 0 to 2 pi. Don't take it 0 to pi. No doubt, while integration again, when wherever it is existing, accordingly we will change the limit. For pi to 2 pi it is 0. So definitely this is of no use. It is not contributing anything. But when we write the expression, so in first step we will consider it as over one period, that is 0 to 2 pi, complete cycle. So on time plus off time. And now there is a repetition. So this is periodic. Period is 0 to 2 pi, that is 2 pi. So 0 to 2 pi Em sin t dt. Now this Em is constant. We will take outside. This is 1 upon 2 pi. So Em by 2 pi. And the limit is 0 to pi sin t. That is, the signal is existing. And from pi to 2 pi it is 0. So sin t dt plus 0 dt. Now this second term is 0. Only for first term, integration is integration of sin t is minus cos t over the period 0 to pi. So cos of pi and then cos of 0. So cos of pi is with minus sign. So that's why it is minus 1, minus 1, and cos 0 is 1. So therefore total it is 2, and this 2 will get cancelled, and therefore C0 will be Em by pi. Now for Cn, it is 1 by t integration T0 to T0 plus t. Then this is m of t e raised to minus jn omega 0 t. Then this is our basic formula for calculating Cn. What is nth term? Cn for exponential form. How it is evaluated? Integration over one period m of t or x of t e raised to minus jn omega 0 t dt. And outside the integration, there is a constant 1 upon capital T, that is fundamental period. Now m of t, that Em term we will write outside, Em by 2 pi sin of t e raised to minus jn. And what is omega 0? We have calculated omega 0 is equal to 1. So therefore it is jn omega 0. Omega 0 is 1 t. In the beginning only we have calculated here omega 0, that is coming out to be 1. So here we substitute that. Now the formula which we need to use is e raised to ax sin bx. What is the formula? E raised to ax divided by a square plus b square into bracket a sin bx minus b cos bx. So here use this formula and write this. Now here it is e raised to ax. It is e raised to minus jnt. A is minus jn. So e raised to ax, this e raised to ax term, e raised to minus jnt divided by a square plus b square. A is minus jn, b is 1. So minus jn square plus 1. So this outside term is as it is written according to this formula. and now into bracket a sine bx. So a is minus zen, sine bx is sine 1t, that is sine t, minus b is again 1 into cos bx, that is cos t, over the period 0 to pi. So do the substitution, em by 2 pi, then this particular jn square plus 1, you can simplify a little bit as per your convenience, you can write this, then ejnt into jn sin t minus ejnt into cos t. So we have expanded this into this, then minus this into this, and whatever this is, j square is minus minus 1, 1 plus 1 2, and that 2 we are just writing out, this 1 minus n square. So this 1 and j square is minus 1, so minus minus plus, so that means 1 into n square, that is this 1 minus n square we are writing outside, we are writing it outside. So therefore here it is, into bracket this whole term, out of that upper limit pi we have substituted, minus jn e raised to minus jn pi, instead of t here it is pi, sine of t, that is sine of pi, minus e raised to minus jn pi cos of pi, lower limit, that is here it is already minus sign, therefore minus minus it will become plus jn e raised to 0 sine of 0, and this minus sign will also become minus minus plus, and therefore it is e raised to 0 cos of 0. So if we simplify, then it is coming out to be em upon 2 pi into bracket 1 minus n square e raised to minus j n pi, only this term is remaining, this is becoming 0, this is becoming 0, this is becoming 0. So first term, third term, fourth term, all of them are zeros. Sin pi is 0, here it is sin 0 is 0, and here it is e raised to 0 into cos 0, that is 1. So this 1 we are writing as it is, and this term cos of pi is minus 1 minus minus plus e raised to minus j in pi. Now if we substitute a little bit, e raised to minus j in pi is equal to minus 1 raised to n. Remember this particular identity, and therefore little simplified form, em by 2 pi, em by 2 pi into bracket 1 minus n square minus 1 raised to n plus 1. So you can write this expression, its magnitude for all values of n. If it is odd value, that is when n is equal to 0, n is equal to 1, n is equal to 3, at that time this minus 1 sign will get minus, so minus 1 plus 1, this whole term will become 0. So for all odd values of n, this term is going to become 0, this particular term, and for even values of n, so this term will become em upon 1 plus 1 it will become, and therefore 2 will get cancelled, and magnitude wise it will become em upon 1 minus n square, that is 2 square, 4 square, 6 square, like that, and into pi. So em by pi into bracket 1 minus n square. So if you are supposed to plot the magnitude plot, then this modulus value, so em upon, this is for 1, 2, 3, 4, so like that, for 1, 3, for all odd values you make it 0, 0, and for even values you can simply mention em by pi, em by 3 pi, em by 15 pi, and so on. So like that, you can plot the magnitude plot for this particular function.